Okay. Okay. Good evening, guys. How did the homework go? What questions do you have? Can you please put them on the chat so we can start talking about them? Anyone? Anybody had any difficulties? Oops. Sorry, I have to pin myself. I didn't pay attention to that. Okay, so let us make sure we get the definitions going for the log before we start working with them. So the question that I'm gonna work with the natural log today. Sorry, yeah, not with the log of base 10 as we call it. So the natural log, so let us remember ln of a number is basically another number, but what does the thing mean? It's the number that I should raise e to get my n back. So ln of y equal y, it means e to the y equal to n. So one more time, the questions that I ask on your exam and on your quiz. So if I write ln of 2 is, let us say, 0.69, it means that if I take the e, and I raise it to this power, I should get the number 2. So the input of 2 becomes the output here, and the output is becoming the input right there. So before we move on, the thing that I want to emphasize a lot is the following. If I take e to the power ln of 2, what should we get back?
2.
2, because please mute yourself. For those who have noise in the background, please mute yourself. So e to the ln of 2 is 2 because that's really what the ln of 2 is. The ln of 2 is what I should put here to get 2 back. That's really what the ln is. So if I give you, for example, the question that I assign, e to the ln of x, regardless what x is, what should we get quickly?
X.
We should get x back. E to the ln of anything is this anything back because that's what the ln means. Ln of x is the power of e that gives me x. So let us keep going. Ln, no, sorry, not this one. E to the ln of 2x plus 10.
2x plus 10.
It's 2x plus 10. So whatever you have here, that's what you get right there. Now, what is ln of some simple one? What's ln of e squared? That's really too many symbolism. But what's ln of e squared? It means e to which power?
2.
Let's give me ln of e squared equal 2. What is ln of e to the power anything you want? 100.
100.
to the x. Back to you now. Don't be
Everybody's
afraid.
muted. It's just me.
Everybody, yeah, please, do you want me to pick? I don't like to pick. Michelle, what's the ln of e to the x? E
It is e
to which power should give me e to the x? What should I put here to get e to the x? I'll back up. Roxanne said ln of e to the 100 is 100. Why is she, Roxanne, is correct? E to which power gives me e to the 100? What should I put here to get e to the 100? And there is one candidate, 100 itself. So ln of e to the 100 is 100. What's ln of e to the x? E to which power will give me e to the x? One candidate, it's x itself. So the two property of ln, the first two property of ln, that I want you to, as much as you can, drill them in your head, is e to the ln of x, of anything, x represent anything, will give me the anything back. And ln of e to anything will give me the anything back. Another thing I want you to be able to know it without a lot of thinking process. What is ln of 1?
0.
0, because e to which power give me 1? E to the 0. ln of e to which powers gives me e?
1.
1. Absolutely crucial. So e to the ln of 2 is 2 back. E to ln of 5 gives me 5, because that's what the ln means. It's the power of e that gives me what's inside the ln. That's really the definition. All right, so before we have to move on, but I want to do practice 4. So one of the problem I gave you, so we can remember all the property of the log. Let us remember how the property of the log. What is ln of a times b? So it means if I have two numbers a and b, I multiply them, I have a new number, a times b. What does ln of a times b equal to?
ln A plus ln B.
So it turns it into a sum. Now, if you have a to the n power, that's going to be very important for me. What does ln do to it? It's bring it down.
Puts the n, yep, in front.
Times
Exactly.
the ln of a.
Very good. The last one we worked with is what happened to the ratio. You have two numbers, a and b. You divide them, you have a new number. What's the ln of the new numbers in terms of the ln of a and b?
ln of a minus ln of b.
Minus ln of b. We're going to use them today. We're going to use those properties, especially this one. That's why I wanted to be very remind you of those properties. So with this in mind, let me do practice. Actually, let me take that and make sure everybody got that one correct. And then I'll put on blackboard once you guys give me the answer. E to the ln of 2. Please, not only Roxanne. I love to hear Roxanne's voice. I want all of you though. What's E of ln of 2? If you don't like to talk, put it on the chat. Is that very clear? You don't want to talk, put on the chat. What's E of ln of 2? Plus 1. To somebody give me the answer.
It's 2.
It's 2. E to the ln of x, quickly.
It's x.
It's x. Thank you. ln of e squared. ln of e to the 5x.
Would it be 5x?
Exactly. 5x. No more, no less. Why 5x? Because what's ln of e to the 5x? You're looking for the number. When you take it to the power e, you get e to the 5x, which gives me absolutely 5x. And finally, what's the ln of the square root of e?
Square root?
No,
Or
One
no,
half.
we don't guess. We don't guess. No guessing allowed. You have to do it everything systematically. What's the square root of e? It's e to which power?
1/2.
1/2.
Oh, so that's how we write it in there? Okay.
Yes, there's no way out. No way out. What's ln of e to the power 1/2 now? What's number? You raise, to which number you raise e to get 1/2?
1/2.
1/2. Okay, there is no way out. It's not, you don't take the square root out. You don't do anything with the log. You only follow the definition and the properties. Don't mess up with the log because you do mistakes. The definitions and the properties. The only thing I will be using to deal with the log.
So if we put the answer as e to the 1/2, it would be wrong. We would have to put 1/2 as the actual answer.
Absolutely, because e to the 1/2 is not 1/2. Very different. E to the 1/2, it means e to 0.718 to the power 1/2. That's e to the power 1/2.
Okay.
And my answer is just 1/2. So definitely not the same thing.
Because it's the natural log of e to the 1/2.
Right, right. The natural log, it means the power of e that gives you what's inside the parentheses. Which power of e gives you what's inside the parentheses? It has to be the 1/2. That's the definition. Okay. Now, I'm giving you a bunch of stuff. I tell you, we have two numbers, a and b. ln of a is p, ln of b is q. Find the ln of those. And the idea is to practice the property. Okay, so what's the first one? ln of a, b, it's ln of a of this number plus the ln of that number. Okay, ln of a is p, that's q, and of that. Now, ln of b over a4. Now I have two numbers, I'm taking the ratio. The property of log is this property. So it's the ln of b minus ln of a to the power 4 equal. ln of b, I gave it to you, I called it p. What's ln of a to the 4? I don't have it. But now which property of the log I want to use? Which I'm going to use
Subtraction.
over. No, not yet. ln of a to a power, is, I can bring down the power, multiply it by the ln. What is the power I'm going to apply to now? ln of a to the 4. This is the power. So the property of the log tells me this power can be brought down times the ln of a. Now, I gave you ln of b, I gave you ln of a, and that's what it is.
It's backwards. It's q
Oh,
minus
thank you. Oh, thank you, thank you, thank you. Okay, now ln of a to the 5. That's the power. Again, I am back into the scenario. I can bring the power down. It's going to give me 5 times the ln, the natural log of a. Now the natural log of a is p, 5p. The last one. Okay, who want to give me the answer to the last one?
Oh, let me look at the rule real quick.
ln of a over e. Please, I want answers, all of you. You should be able to write it up and give me the answer. Get going.
A minus.
It's just ln of a, right?
On what basis?
The fact that
P.
ln of e will cancel out when you minus
It would
it.
be
Nope.
divided.
Which rule you're
Or it would just
using?
be, or it would
Which
just be
rule
1.
you're using?
I know which one.
Is ln when it cancels out 1 or 0?
Nothing.
It doesn't
cancels out.
cancel.
Nothing cancel. What's ln of a over the e? You
It's
have
ln A
ln A minus
ln E.
ln E.
it's ln of a minus the ln of e. Nothing is canceling so far. Be very careful. Be very careful.
And the ln of E should be 1.
Right. ln, yeah, 1 minute, Don. ln of a plus b is not ln of a over the ln of b. And I think the student who said ln of a is having that in his mind. This is
No, I
not.
just meant minus.
It's right.
I just didn't know if the ln was going to be 1 or
That's okay.
0.
That's all right.
I
So
forgot.
this is ln of a minus. But what's ln of a? We know is ln of a. What's the ln of e? And that's
1.
crucial. 1. Because what's ln of e is which power e should be raised to get e back. It's 1. Okay, so we write this down again. This is the ln of a minus the ln of e. And the ln of a is a p minus the ln of p is equal to 1, the of e. And we get p minus 1. Okay, so we are gonna use the rules verbatim. You keep them in front of you. And 2 things to remember. The 2 things to remember are the very crucial things to remember. We have them, of course, I wrote them in your notes because they are crucial. ln of 1 is 0 because e to the power 0 gives me 1. ln of e is 1 because e to the power 1 gives me e. E to the ln of n is n. And ln of e to the n equal to n. Okay, because this is the definition of ln. This piece is follows verbatim from the definition. What's the ln of something? It's the power of e that gives me this something. And this, again, because what's ln of e to the n? I'm asking you to which power of e you get e to the, what's inside? Okay, you have to have this is exactly that. All right. So today we're going to use this new function. We call it ln of n, which have those properties. And mostly this one, very important property. And we're going to use them to go back to our initial problem. So our initial problem was the following. Our initial problem, before I'll take my notes, was you put money in the bank, you put like $1,000, and it grow at the rate of 3%. And you ask yourself, how long it's going to take for my money to grow to, let us say, 1,200. So you need to solve this problem, and your unknown is an exponent. It's right there. The question is how I'm going to do with it. This is a hard problem. It's not easy at all. I can solve problem like 2t equal 15 when I'm multiplying. But I can't solve problems so far when my unknown is a power. And that's what's going to be what we will be doing actually the whole day today. Solving equations where the unknown is a power. So I'll start with my first problem, which is in your notes, so to make it easy for us, but I'll do it slowly in front of us. So my first problem is we're going to solve the following for x. 2 to the power x equal to 3. Okay? My unknown is an exponent. So I am asking you which exponent should go here so that 2 to this power equal to 3. Now x should be, I don't know, bigger than 1 because 2 to the 1 is 2. X should be less than 2 because 2 squared is 4. So x is somewhere between 1 and 2. But the problem is what's the exact value of x, and that's exactly what we're going to be doing. The problem is x is an exponent. That's really my issue. So how are we going to do those problems? So I will do the first one slowly myself. I will do 2 problems myself. And notation here is crucial. I'm going to say that those 2 problems equal to 3. I'm going to take the logarithm from both sides. I said, since those are equal, I will take the natural log from both sides. It means I said, this term is equal to that. It means the natural log of this is equal to the natural log of 3. And why we do that? And what's the importance of this step? What's going to be the most important step? 2 numbers are equal, their natural log are equal. And now I'm going to use the extremely powerful property of the log. That I'm going to write it because I'm going to use it. Tells me that if you have log of a number to a power, it's equal to what? It's the power times the ln of a. Crucial property. So this property of the log will help me to bring the power, the unknown, from the top as an exponent to something I multiply a quantity by. So how I'm going to use this? This is my x. That's the power. The log property tells me I can bring this x down here. And this will turn into x multiplied by the log of 2. This is equal to the natural log of 3. Let me remind you that ln of 3 is a number. This whole thing is a number. We're not going to be afraid of it. ln of 2 is a number. So now what did I do? X, which is an exponent, is not an exponent anymore. By taking the natural log from both sides, this x came down here. And now I have x multiplied by this number is equal to that number. So we're going to solve for x. How can we solve for x? This is a number, and this is a number. So I'm going to divide those by the ln of 2. And that will give me my x. So now it's really a matter of going back and dividing. And we're going to try to have some. So it's ln of 3 divided by the ln of 2. And I'm getting 1 point. So this is almost 1.5849, the first 4 digits. And
What's that little symbol that you wrote?
You tell me, what do you think? Anybody can figure it out? Almost, no. Almost, because I am rounding. So when we write this, it means it's almost equal because I am rounding. Okay, so if it bothers you, you can write equal, but a lot of people will write approximately equal because we have rounding going on. It's not the exact value. It's an approximation of the value. All right, so let us check our answers a little bit. So I'm going to take 2 to this power, 1.5849, and ask myself, am I getting 3? We should get 3, you know, with certain. So I'm going to take the 2, because that's what I'm looking for, and I'm going to raise it to the power 1.5849. I'm getting 2.99999, so it's basically almost equal to 3. My question is, okay. Now problem number 2. Again, I will do both problems myself fully to give you a feeling. So now I want to solve the following. 5 times 2 to the x equal to 3. Okay, so it's almost like before, but not quite like before because I multiplied by x. And this is a natural problem because when I started, what our goal is to solve something like 100 equal 120. So I'm going to always have this number here. So how do we approach those type of problems? What's going to be our first step?
I would
What
say
bothers you bothers me. What's bothering us?
The 5.
The 5. We're going to divide by 5 both terms. So we don't
Oh.
have to deal with 5 at all. And then we're going to go back almost to the first scenario. So always, when you have 5 times this, my idea for you is you have to isolate the exponential term. Isolate the exponential term. So you come back to the scenario. That's why we isolated. Now, how can we isolate the exponential term? We have to divide by 5 both sides. So we're going to divide by 5 both sides. So I divide this by 5. This 5 is gone, but this has to be divided by 5. So I will end up with 2 to the x equal 3 over 5. 3 over 5 is a nice number. It's a very nice number. If I evaluate it, 3 over 5 is 0.6. So it's not really a bad number because it's exactly 0.6. I'm not even rounding in this case. Now I am back to my original problem. So now I am back to my original problem. I need to solve a problem where my unknown is an exponent. And somehow we have to get rid of it. So we said if those are equal, the natural log of the first is the same as the natural log of the second. And that's really, once we do this step, then we use a lot of algebra. So step number 1, isolate the exponential. Once I isolate it, I say since those two are equal, their natural log is the same. And then the important property of the log. Log of a number to a power, you can take this power and bring it down. So this is only become x times the natural log of 2 equal the natural log of 0.6. Remember, this is a number. It's not really a variable. And this whole thing is a number. We can pick it up. So I'm going to divide by that number. It's ln of 0.6 over the ln of 2. And that's, once we get that, that's the exact value and the approximate value, because sometimes we like to have a feeling of what those numbers are. Sorry. It's ln of 0.6 divided by the ln of 2, and I will get, at least I'm getting, negative 0.7369. Okay, and now we can check. It means I plug in this value of x in here, and I get 3. So let me check, just to make sure. Check. I'm going to take 5 times 2, and I'm going to raise it to the power minus 0.7369. And am I getting what I want? So I will do it right here. 5, that's my 5, times 2, 2 is here, to the power, I open my parentheses because I have a negative sign, negative 0.7369, I close it, and I'm getting 3.0001, which is basically almost a 3, end of the problem. Okay, so that's really the basic idea of today. So we're going to have variation of those problems, but that's the idea. Whenever my exponent is the unknown, the log will have to come into the picture. But you have to do it really, really very carefully, because we have to abide by the rules that the natural log have. So once we isolate my exponential, this format, we say since those numbers are equal, their natural log is equal. We use the main property of the log, which will allow me to bring the exponent down. Once this happens, I'm dealing with a simple algebraic equation where I have an unknown in power 1, and then the rest are a bunch of numbers, and I can solve it. Okay, so before we move on to more, if you guys have the notes in front of you, I'm giving you some practice problem. So we're gonna do practice 1. All right, so if you guys have a piece of paper, I did not give you any answers because I want you to work with me. So the practice 1 is I want you to solve 3 times, sorry, 4, this time to the power 2x equal to 7. So you have to solve for x. All right, so you guys work with me. What would be the first step?
Divide by 3.
Isolate the exponential term. So we're going to divide by 3. Okay, so this will give me 4 to the quantity 2x equals 7 over 3. Now 7 over 3 is not really a nice number, right? 7
No.
over 3, so forget it, keep it 7 over 3. If it's nice, not nice, we're gonna keep it. What's now gonna be the second step? What? Questions? Okay, what's gonna be my next step? Remember?
We're going to drop down the 2x.
Not yet. We cannot drop it by magic.
You need,
There's 1.
you need to do ln of 4 2x.
Right, we have to take the log from both sides. I said, since those are equal, the natural log of the first equal, then the natural log of the second. That's the crucial step. Okay, it's like if I say 2 equals x equal, no, that's not equal to x. All right. So now I use the property of the log, which tells me, you see, this is your power now, 2x. And it's your 2x that you can bring it down. So be very careful here. The power is not x, the power is 2x. So I'm going to have 2x times the ln of 4 is the ln of 7 over 3. Now I need to solve for x.
So we're going to divide it by 2.
I divided by 2. Okay. Anybody else would tell me how would I solve for x?
Well, what I was thinking is I would divide the ln by 4 under the ln of 7/3 and then figure out what that number is and then divide by 2 after all that, but I don't know.
So you want to divide by ln of 4?
Yeah, my first step was that.
Okay, you're absolutely, and then your second step is?
Divide by 2.
Yeah, you're absolutely correct. Can we do them in one step?
I don't know. Can
Yes.
Yes. What
Write it
do
as
I mean
x
by
times 2 ln.
we're going to
of 4.
divide by, what you said is absolutely correct, but we can do it in one step by dividing by 2 times ln of 4. Let's see. Why is this easy? Because you're going to have 2x times ln of 4 divided by this equal ln of 7 over 3 divided by 2 times the ln of 4. Is this mathematically correct? Remember, this is a number. Don't
Yeah,
be
because
afraid.
it leaves you with x. We're able to cancel
Right, the
2s
2
and the
and the 2
LNs out.
cancel, ln of 4, ln of course cancel, then you will have your x equal ln of this quantity over 2 times the ln of 4. Now we have to be very, very careful, but we just have to compute this number. Did the student who asked me this question understood why I did both in one step?
Yeah, I got it.
We can do it by, as you said, first divide by ln of 4, get the number, and then divide by 2. You're absolutely correct. You can do it this way. I have no problems with it. Or you can say, I can divide by 2 times the ln of 4 all at once. And now let us compute this value. I'm going to do them separately because I want to avoid mistakes. And then I tell you how you do it all at once. So I'm going to compute the numerator, ln of 7/3, which is going to give me 0.84729 if you want. I'm going to compute the denominator, which is 2 ln of 4, which is 2.7725. And then I'm going to divide. So I'm going to take 0.84729 divided by 2 point, that's a point in here, 777758. And if I'm not doing any mistake, I'm getting 0.30524. Did anybody get anywhere close to me?
So we can't do it just ln 7/3 over 2 ln 4 because
Yes,
I got a whole different number.
Right. Another way to do it is instead of finding the numerator by its denominator, you can do ln of 7 divided by 3. Sorry. But then you have to divide this by, but now you have to open your parentheses. 2 times ln of 4. If you don't do that, your calculator will not understand that you're dividing by this whole thing.
Oh,
The calculator is not smart. You are. Okay? So it's ln of 7/3 divided by, you open your parentheses, and you put 2 times ln of 4 within your parentheses, so the calculator understands that your denominator is 2 ln of 4. And then you get it 0.0 whatever. You get the exact same thing, and that's how give you a more accurate answer than the one we did. But I will accept that in case, but you should know both. Okay? All right, so we're gonna do still with the practice before I move on. And this time I'm asking you to solve, so 2 more practice and we move. I'm asking you to solve the following. Okay, get a nice piece of paper. And this one is solve the following. 3. Now you know that we studied continuous rate. And the continuous rate, the equation would look like e to the power rt. So suppose r is 3% t. So you put money in the bank at a continuous rate of 3%, compounded continuously, I mean. And you put, let us say, 3 million. Imagine, dream that you have that much. And my question is, how long it's going to take for it to grow to 7 million? That's really my scenario. And my question is, solve 40.
It's not 7 though, it's 7 million, right?
Yeah, but you don't have to write it at a 7 million. It will not be very smart. We know that the unit is a million, so we can just keep it a 7. So this will mean 3 million. This will be 7 million. So, but we don't have to write 7 million. But we understand that that's the unit that we are working with. Okay, so it's an E, but remember E is just a number, so it shouldn't really scare us at all. All right, I'll give you 3. I give the class, every one of you, I'm going to give you 3 minutes. And please do it in front of you and see what you can get with that before I take it. Now, I don't see you, so you guys can be eating if I know. I don't know. I don't know what you're doing, but I want you to pick up a piece of paper and work this problem and see what you do. So when I work it, you know your mistakes. Okay, how far are we? Anybody finished?
I got to the point where it's ln e to the power of 0.03t equals ln to the 7 million over 3.
Yeah, we're not gonna write 7 million, we just write 7, okay?
Oh, okay, well 7.
7, we write 7, forget about million, just solve this with the number given to you. Okay, so let us go through the first step that your classmate, we're gonna isolate the exponential term, giving me that 7 over 3. Now we're gonna take, of course, this is somehow I wanna get rid of that. That's really the bottom line. I wanna bring this down. So I said the ln of the first equal the ln of 7 over 3. I'm using ln, that's the natural log. All right, has everybody got that step? Got here? Now,
Yeah.
again, the property of the log. ln, I keep rewriting it, a to any power can bring the power down times the ln of a. So now I have ln of to this power. That's the power. And this power could be brought down. So if I use this, there are two ways of doing this problem. One way is apply this verbatim. So it's going to give me 0.03t, that's the power, times ln of what?
Okay, it would be the ln of e, right?
It will be the ln of e, because that's what playing the role of a. So what playing the role of a is e, the number e.
Right.
What's playing the role of the power is 0.03t. That's the scenario here.
Right.
ln of e. But we know what ln of e is.
Right.
ln of e is
Equals
1.
1.
So this would leave me 0.03t is the ln of 7 over 3. And my t is, now I only have to divide by 0.03. So I can only divide by 0.03. I don't have, like the previous problem, two quantities. And that's give me ln of 7 over 3 divided by 0.03. In this case, because e to the 0.03 I had, this makes the problem slightly easier than before. Definitely easier.
What did you do to the ln of e? I'm sorry.
It's
ln
1.
of e watch equal to 1. Why ln of e is 1? I always go back to definition, because what's the ln of something? It's the power of e that gives me what's inside the parenthesis. What's the power of e that gives me e? It's 1. Please keep doing those problems and keep reminding yourself of the definition, because it's a new function. It's a new symbol that we're learning. So finally, I get the answer. And this one is going to give me, I'm getting 28.243. Anybody getting anything similar?
Yep.
Yeah. It means if you put $3 million, you add the 3% compounded continuously, it will take a little bit over 28 years for your money to grow to 7 million. Not too bad. So if you guys start saving from now, you see you can have a lot of money in the future. You guys are still young.
But first we need to start off with 3
Inflation's
million.
at least 3%. So
And don't even dream about it now. All right, I'll do one more problem and then we move on. So the last problem I want you guys start with is, again, I'm gonna get 3 times 4 to the 2x plus 3, make it tiny bit complicated, not much, equal 7. Again, I'm gonna give you a few minutes for you to interact with it and do mistakes or get stuck or something, and then we take it. So I will rewrite it again, because I need a whole piece of paper. So again, 3, 4 to the 2x plus 3 That's the term equal to 7. And it is solved for x. Again, don't be afraid, just use it exactly the way we're doing it and use the properties, nothing more, nothing less. It's a bit messy, but we'll get through it. So what's your first step, everyone?
Divide by 3.
Divide by 3. What's our second step?
Ln, natural log both sides.
Immediately, because I have a power. So it's ln of 4 equal ln of 7/3. Now, what is my power here?
2x plus 3.
That's my power right there. That's my power. So in the scenario, ln of a to the n, the n is 2x plus 3. The a is 4. So this is going to be equal to the quantity 2x plus 3 ln of 4 equal ln of 7/3. I know it looks complicated. I'm aware of that. How do you think I want to solve for x?
Minus 3.
By ln of 4.
I cannot take minus 3
Damn it.
before, because this whole expression is multiplied by ln of 4.
What I did was I did the whole thing like you did on the other one. So I did 2 plus 3 times ln of 4 divided by ln of 7/3 over 2 plus 3, or 5 times ln of 4.
Oh boy, you lost me. Honestly. So I have to write what you said because I can't really tell me what you did.
Oh, so what I did is, so I did 2, because you gotta you gotta isolate x, right?
Yes.
Okay, so it's gonna be on the left side, there's gonna be x, and then I'll tell you, and then x equals ln or 7/3 divided by 5, because 2 plus 3 is 5.
Uh-oh.
You're multiplying, you can't do that.
Then
Uh-oh. It's 2x plus 3. How you cannot combine those? Are you with me?
yeah, but I was isolating the x.
You can't isolate it yet. We have a
Right.
problem to isolate x.
Oh.
Still, it's
Do we
2x.
divide by 2 first?
You can't divide by 2 first.
You have to divide by ln
The
of
easiest
4.
way is divide by ln of 4.
Okay.
Why? This is the easiest way. Because all of us, let me repeat. If I tell you solve 2x plus 3 equal whatever, 100. Do we have any issue with that? We bring the 3 here,
Right.
and then we divide by 2.
Right.
Now, if I tell you, for example, divide, solve, make it more complicated. Let us say 2.47. So one way you can do it is say, let me divide by 2.47 first. then I will end up with 2x plus 3 equal in number. I can proceed after that. That's the logic we're using, and that's the easiest way to do it. So divide by ln of 4 will isolate the expression 2x plus 3.
Okay.
Okay, now it's not hard anymore. To make it easy for us, I'm going to estimate this expression and then I will proceed. So I'm going to estimate ln of 7 over 3 over ln of 4. So to make it just a number, so I work with numbers. So log of ln of 7 over 3 divided by ln of 4. So we're getting 0.6112. That's a good approximation. At this stage, it's simple. I take away the 3 from both sides. I compute that. Minus 3 is going to give me minus 2.388. Sorry, 888. So I can put 888. And then I divide by 2. And that's what's going to give me x equal. We divide this by 2 and 1.194. That's enough approximation. So let us sum up a little bit. Step 1, isolate crucial. Step 2, take the natural log from both sides. What this will help me is to bring the 2x plus 3 down. Now, the difficulties of this problem versus the other, that this expression is multiplied by ln of 4. So how am I going to move the 3? You can't move the 3. You want to get rid of the ln of 4 and then you can move the 3. How can I get rid of it? Divide both by it. At this stage, we have a simple problem. 2x plus 3 become, you evaluate this and then we solve for x. So the process is always the same. There will be a small modification between one problem and another. Okay, so let us do one problem for practice. You know, and of course there are a lot of practice here. So my problem now is simple. I will do one of those practice problems. Practice 4. That's a simple one. Joe invested $5,000 in an account that pay an interest of 2% compounded annually, the simple kind of interest. My question is, how does it take for the money to grow to 6,000? So you go to the bank, it gives you 2% annually, you have 5,000, and you know you want to buy something. So you ask yourself, okay, how long shall I deposit to get 6,000? How shall I solve this problem? Okay, I'll let you think about it for 2 minutes before I set it up.
Times.
Please, every one of you do it. Every one of you.
2t.
Right? Anybody?
Do it on the calculator, but I'm done.
Okay. Anybody else? Yeah, you're still working on it. Okay, I'll give you 1 more minute if you guys working on it. First, I want the setup. How do you set up the problem? And then how do you solve? So it's setting up and solving, setting up and solving. All right, are we ready?
Yeah.
Okay, anybody else? Everybody? I mean, I hope. Okay, who'd like to take over?
Probably
So-
me.
I started f of t to be the amount of money in the bank after 3 years. We're doing the setup. So the formula of f of t is the initial, 5,000, times it's annually 2%, 1.02 to the power t. So that's the amount after 3 years. So we have really to start setting up the problem. Now I'm asking, how long does it take for the money to grow? So now my question is, we need to find the t such that f of t equal to 6,000. That's what I mean by the setup. That's exactly what I mean. Means you have to find time such that 5,000 times this equal to 6,000. This is obviously a problem like what we've been doing. We need to isolate the exponential term. So we divide by 5,000 both sides. So I will have 1.02 to the power t equal 6,000 over that. It means 6 over 5. Now 6 over 5, I think that's a very nice number, right?
1.2.
It's 1.2. Because it's a nice number, we don't have to worry, we're not rounding or anything. Now I'm going to take the natural log from both sides. So I have the natural log of the first equal to the natural log of the second term. So this is 1.0t to the power t. And then we use this property of the log, as I said, it's crucial, which will allow me to bring the t down. T times the ln of that equal the ln of 1.2. And now the final step, this is a number, and this is a number. We divide by that number, ln of 1.2 over the ln of 1.02. And now I pick it up and I compute. So it's ln of 1.2 divided by ln of 1.02. And it's 9 years and 2/10 of a year. Okay, so it's 9.2 years. So you have to wait, okay, 9 years to earn one extra $1,000. That's a long time, but whatever. All right. Now practice 5, I will leave it as a homework because I've done something pretty similar to it. And I'm going to talk about a new definition, but it's almost the same thing. The idea of doubling time. You guys, especially these days, you hear a lot about the doubling time. You know, we talk a lot, if you guys listen to the news, you hear a lot the word that the doubling time of the virus is like 4 days. The doubling time, when they're talking about it improving, they give you the doubling time. The doubling time now is 8 days. What does doubling time mean? So doubling time. Okay, you guys have all those in your notes. What is a doubling time? So suppose we have an exponential function or something that's growing. It has to be grow. So it starts somewhere that is growing. So initially, let us say its value. So my function is f of t equal a times b to the t. So initially, the value is a. This function keeps growing, and what happened to it is that at some point its value doubles. It means doubling, it means its value is multiplied by 2. That's really what doubling is. So it's a, and then at some point its value is 2a. It's multiplied by 2. And then it's multiplied again. It becomes 4a. The doubling time is the time needed for the function to double its value. That's what the doubling time is. So that's the doubling time. Okay, it's the time period required for the exponential function to double its value. So it's 100, how long it's gonna take to grow to 200? It's 200, how long it's gonna take to grow to 400? So doubling time is actually the time needed for an exponential function to double its value. Now, what we can show is that the time it needs to go from A to 2A, suppose we find it, to double again, it means from 2A to 4A, it takes the same amount of time. So that those will be actually the same amount of time. So the time to go from A to 2A, if it's an exponential growth, will be the same time to go from A to 4A. Will be the same time to go from 4A to 8A. So the doubling time really is constant. So how to find the doubling time? Very natural. So I'm gonna take the first problem and then I will give you the second problem. So once we understand the definition of it, finding doubling time, it's actually not really hard at all. Let me see if I can find my numbers. I don't think I can find them. Okay, give me 1 minute. So, a simple scenario. Suppose you have in a town, a population is growing, and it's growing according to this formula. So I gave you the formula. So we can make up actually any data I want. So 100 to the power t, and suppose the rate by 14.5%. So that's the population. So graphically, the population start at t equal to 0, it's 100, and it's growing exponentially by the same percent. It means growing by 14.5% every year. And my question is, find the doubling time. Okay, what does it mean? It means I'm asking you how long it takes for the population to double its value. So how can I set up the problem to be able to find the doubling time? Can anybody tell me?
Multiply 100 by 2.
Yes, and?
Set the formula equal to that number.
Right, because I want to find the time for the population to double. Initially, at 0, the population is 100. And my question is, I need to find the time, how long it took for the population to grow
100.
to 200. Doubling time, it means I need to find the time for it to grow to 200. So this is my population. My question is, how long it took it to go from 100 to 200. At t equal to 0, we are at 100. How long it took to go from 0 to 100? Do you think that's an easy problem or a hard problem? So now my output is, my output is 200. I want to find the input t that gives me an output of 200. So I'm going to set 100 times to the power t equal to 200. And I need to solve 40. So that's really what the doubling time is. Very good. Now, we know what to do. That's a simple scenario. We divide by 100 both sides. So if I divide by 100, this will give me to the power t, 200 over 100 will be 2. And now I'm going to solve for t. To solve for t, I will take the natural log of the first term, whatever it is, since I isolated my exponential, is the natural log of the second term. And this term here is 1.45 to the power t. T is my power now. I have to bring it down. So I will have t times ln of 1.145 equal to the ln of 2. This is a number, and that's a number. And so t would be over, and this will allow me to find the t. It means how long it's going to take. That's what we call it, the doubling time. So I will get ln of 2 divided by the ln of, ln of 2 divided by the ln of 1.145, which is right?
You did something wrong because I got 5.119.
Yeah, I am multiplying them, and I'm staring at my answer, and I'm not liking it. It's not making any sense to me. Okay, I'm getting 5 points. It's going to take 5 years and a little bit more, and 1/10 of a year almost. And that will be the doubling time. Okay. Now, so to grow from 100 to 200, it took 5 years. Now, I told you something, and I want to now make sure that I told you that how long is going to take it to grow from 200 to 400?
Same amount of time.
What do you think?
Nope. Nope.
Is it going to be the same amount of time?
No, because it's exponential.
But
It's
exponential,
200 to 400, not 200 to 300.
yeah,
So she's
exponential
doubling it.
function grow by the same factor. It means what happened in the exponential. Let us remember how the exponential grow. 0 after 5.11, so it was 100, 200. From here to here, you multiplied by 2. And from here to here, we added 5.11. The way the exponential grow, if you add the same amount, it will grow by the same factor.
Oh.
If you add the same amount, it grows by the same factor. That's the exponential growth. So if we add the same amount, it's going to give me 10.22. It's going to be multiplied by 2. So it's going to take exact same amount of time to grow from 200 to 400 because that's an exponential growth. And here, if it's multiplied by 2, you're adding that much time, you multiply by 2, adding the same amount of time, the output will be multiplied by the same factor. That's the property of the exponential growth. Okay. Very good. Now I have another problem for you. And again, with the doubling time. And my question is the following. In this problem, I did not give you the initial value. And I told you the following, and I want you to solve it. Joe invests his money in a bank that paid 4% compounded continuously. sorry, compounded annually. Let's not worry about continuous, it's the same scenario. The question is, so he invested money and the money is growing. And my question is, find the doubling time. Be careful, I did not give you the initial value. I just gave you the rate. And I'm asking you about the doubling time. So how do you want us to, how shall we solve this problem? And the question is, does it matter what we start with? That's the goal of this problem.
So it starts at, I don't know if it starts at 0.
It can't. You're depositing money in
Doubling
the,
0 is just going to be 0.
yeah, we're depositing money in the bank. If you deposit 0, if you deposit 0, you're never gonna double your money, right? So we're gonna solve this problem, and we don't know the initial value.
So it's annually, so it'll be by 12.
Mhm.
So hold on, so it'll be f of t.
F of t equal, now we're talking,
I think you
annually, and it's 1.
Okay.
right. So it'll be 1, it'll be parenthesis 1
Equals A.
A,
over
all
12.
of you, we can solve it together.
1.0 parentheses 1.04
04
to the T.
to the t.
Okay, I stop. Do you guys agree with them?
Yes.
We don't know A, and I don't want to worry about my A. I'm just going to call it A. Right? Because it doesn't really matter. That's the goal of this problem, that it doesn't matter what we start with. Let's call it A. What do we want? We
We want to
want,
set that to 2A.
right, we want to set this, we wanted this to double. Means, and my question is, when will my money, whatever it is, double? So the question is, we're going to find T
In terms of A.
such that f of t equal how much? 2 times A. And don't be scared, you will see what's going to happen in a moment. So I don't know the initial. I'm going to call it A because I don't know it. But I know the rate. So I have a good idea about how the formula is except for A. But my problem is to find how long it took for the principal to double. So that's really what I want to solve. F of t equal to A. So it means I want to solve the following problem for t. T is really my unknown. It's like a curious thing. Equal to A.
So do we divide by A first?
We have to, because that's how we solve exponential functions. We divide by A. And what do we get?
We get 1.04 to the T equals 2.
We divide by A both sides. Now the A simplify, it's going to give me this equal to 2. So what's the point here?
A doesn't matter.
It doesn't matter.
Starting
The
value
initial-
is irrelevant.
right. The initial value doesn't really matter. It's only actually the rate that matters for the doubling time. If I know the rate, I know how long it will take for the money to double. Whether you start with $1 or $500,000 or $1 trillion, the amount of time for your money to double really depends on the rate, not on how much you put initially. Okay, so now the problem is simple. I can take the natural log from both sides equal to the natural log of 2. So 1.04 to the power t. Now my t will go down. ln of 2. Now I divide by ln of 1.04. And this will give me my t. I think that's the same one. I didn't know. It's different.
17,672.
17.672 years. So the doubling time is 17 years. So regardless what you start with, it's going to take a little bit over 17 years for your investment actually to double, whether you start with 1 or 2 or 3. So the doubling time, go ahead, Roxanne.
It's basically just saying whatever it is at 4% takes 17 years to double.
Absolutely.
When your interest is 4.
Absolutely. Regardless what you start with, it doesn't matter. So the doubling time doesn't depend on the initial value. It's actually only depend on the rate. It only depends on the rate. And it's the same. That's why going from 2A to 4A, we get exactly the same answer. Doubling from here to here, because the initial value didn't really matter. So even going from 2A to 4A is going to take also the same amount. That's how long it's going to take for your income, for your money actually to double. All right, the last thing I'm going to mention, which is it's all the same ideas. I mean, even though we seem like we're talking about a lot of things, but it's really boiling down to how really we use log to solve those type of equations. So it's just different word, but the basic idea is how to use the log to solve equation where the exponent itself is a power. That's really what our concern is. Now, the last thing I will mention, but I want you guys to give me the definition, and I don't want Roxanne to talk now. I want other people. Okay? No offense.
None taken.
If nobody give me an answer, you will. What's the half-life? Suppose a function decreases. Right? So we cannot talk about doubling time. Doesn't make sense because it's not going to double. So what do you think the half-life means of a function?
It would be for any formula where the rate is less than 1. It would have half-life rather than a doubling time.
Yeah, but doubling time was the time period needed for a quantity to double its value. So it's very specific.
And a half-life is the amount of time needed for the amount to be reduced by half.
Right, to be reduced by half. So that's what really the half-life. How long it would take for my function so that the value will be decreased by a half. So it means if you start by A, how long? That's A. I want half of this. How long is going to do? How long is going to take? I need the time needed. The time needed for my function to decrease by half its value. That's the half-life. Okay. For doubling time, we're doubling. For decreasing, for a decay, of course, we talk about the half-life of whatever the quantity we're looking at is concerned. So if I'm, for example, if I'm drinking coffee and the caffeine get into my body and that I start with 100 milligram. Okay, my question is, at how long it takes for only 50 milligrams to remain in you? So that's really the half-life of anything we use. Okay. And in my notes, and actually now in the homework, you're gonna have to compute the half-life. And it's basically the same approach because you just send your function to be equal half your initial value. And then you ask how long it takes for my function to take half of what it's starting with, and we get immediately the half-life doing those type of problems. All right?
Yep.
Any questions before I move on? Please make sure to do the homework. Whenever I teach the log, the problem I have is really with the notation, and the notation become really, really weird. Think of it always as a function. It means that's a rule. So ln is your rule, and parentheses, you have your input inside. So ln is the rule that take a number n to something we call ln of n, which is this power that gives me n. So working with the notation, writing correctly will at least help you to manipulate those type of problems. All right, that's it for tonight. You guys, please do your homework. Please make sure you do every single one of them. And next time we will discuss the homework, and we still have a little bit we will talk about it. All right, anything before I let you go? Remember, your exam retake is due tonight at 11 p.m. I hope you guys worked on it. All right, any questions before I let you go? Sure. Anybody else? Thank you. Thanks, Roxanne.
You guys have a good dinner. Bye.
You too. Bye-bye, guys.